Okay, class, let's talk about solving one-step inequalities. But today we're going to talk about multiply and divide. But before we do that, let's do a little review of what we did in our last lesson, which was over addition and subtraction, just to make sure that we understand what we're doing. Okay, so in this first problem, it says I have x plus 8 is greater than 3. So what I'd like for you to do is solve this one. Okay, to solve this, I need to get rid of this plus 8. To do that, I add a negative 8, or I just subtract 8. So we got x plus 8 minus 8, because we know plus and minus negate each other, is greater than 3 minus 8, because that's what I put in on this side, so I do the same over here. And most of us are getting mature enough mathematically that when I see 3 minus 8, I know my answer is going to be negative 5. If we don't understand that, then we do our LCO, we change it, leave, change opposite, and now we have a 3 plus negative 8. Our signs are different, so we subtract our numbers and take the sign of the number with the greatest absolute value. And now we graph this. And we know if it says x is greater than negative 5, then I come down here, I put an open circle on 5 because it does not include negative 5, and I shade to the right. So there would be our graph of that particular problem. Now for the second one, our letter's on the right-hand side of the inequality. It's really not that big of a deal. You just start here at the inequality and start working. So m minus 2, well, to get rid of a minus 2, we do a plus 2. So then I'm going to put this plus 2 on the other side as well. Negative 4 plus 2. So we end up with negative 4 plus 2 gives us negative 2 is greater than or equal to m, or m is less than or equal to negative 2. If you do flip it, make sure you flip the inequality. So in this one, we need to graph m is less than or equal to negative 2. So we put a closed circle on negative 2 because the equal says it includes negative 2, and we shade to the left because I need less than or left of. Okay. Now today what I want to talk about is multiply and divide. So let's review multiplying and dividing equations. Well, first off, we have 4x's here. 4x equals negative 12. Well, I don't want to know about 4x. I want to know about a single x, or 1x. Well, to turn 4x's into 1x, I just divide it by 4. That's all I have to do. And if I divide one side by 4, I divide the other side by 4 as well. And we end up with x equaling negative 12 divided by 4 gives us negative 3. Now, as we've talked about in some of these problems with equations or inequalities, it's best if we check our solutions to see if they work. So I would take this negative 3 and plug it back in. 4 times negative 3, and ask, does that give me negative 12? And sure enough, it does. So this one checks out. We would do the same thing on a problem with division. If I have a divide by 5, or 1/5 of 5, that means I need 5 of these pieces in order to get a whole. So I'm going to multiply this by 5, and if I multiply this side by 5, I need to multiply the other side by 5 as well. So this 5 on top simplifies out with the 5 on bottom, and it turns into 1m, which is what I want. Please remember, 5 over 5 does not turn into 0. It divides out to become a 1. And then m is equal to 4 times 5, which is 20. And again, if we were to plug this value back in, 20 divided by 5, does that equal 4? And sure enough, it does check. So that's what we did with solving equations. Well, just like with inequalities, we found out that we solve them exactly the same way as we do with equations. We're going to do the same thing with inequalities, with one minor exception. And we'll see that in just a moment. So here we got a 3x is greater than 15. To solve that, we have a multiply by 3. So we still do a divide by 3, just like we did in an equation. So we divide the other side by 3 as well, and you end up with x is greater than 5. Now, like I said, smart people check their answers. So if this says the solution is going to be x is greater than 5, I need to pick a value greater than 5 to check this with. So why don't we use the first one, 6. So we plug in 3 times 6, and we get 18. And we ask, is that greater than 15? And sure enough, it is. Now we're going to do a quick graph on these. What I call a quick graph, we just take right in the center, we put the number of our solution, and then we graph it accordingly. Okay, so this is a greater than 5, so that means it's an open circle, and we shade to the right. because I need all values greater than 5. With a division problem, we work these the same way we did equations as well. I have a divide by 7, so we do a multiply by 7. So I multiply this side by 7 as well, and we end up with r is less than or equal to negative 28. Now when you're doing a division problem and you're checking those, we have to be selective as to what we choose. So this says I need a value that is less than negative 28, or left of on the number line, and divisible by 7, because I want it to come out nice. The first one we have that will do that is negative 35. So if I plug in negative 35 divided by 7, you end up with negative 5. It is negative 5 less than or equal to negative 4. And yes, it is. So now to do a quick graph, you just put a negative 28 on our graph. We're going to put a closed circle on 28. And this says that I'm going to do left of or less than negative 28. Just like that. So we find out that to solve inequalities with multiply divide, the process is exactly the same. Unless your coefficient, your number with your letter, is a negative. If this number is negative, in the process of solving this, our inequality is going to flip. So I kind of imagine this or think of this as a fish hook. When you're fishing, okay, if your fish bites on that hook, it's going to take off running. Okay, and when you set the hook and you start reeling the fish back in, it's going to snag and flip that fish over. And that's what this little hook does. So whenever we're solving this problem, we're going to do it just like we've been doing. I have a multiply by negative 5. So we're going to do a divide by negative 5. And we're going to do it on both sides. But in the solving, when I move this negative over to the other side, this inequality is going to snag and flip. So this is not going to be g is less than negative 4. It's actually going to be g is greater than negative 4 for our solution set. So what we've got to think about whenever we're checking this to make sure, because I've been talking about checking in every slide so far, we need to pick a value in the solution set to see if it's going to work. So I need a value greater than negative 4. Okay, so the first value, if we look at our quick graph, okay, greater than negative 4 is going to be values that are to the right. And the first one that's there is going to be negative 3. So if I were to come up and plug in negative 3, negative 5 times negative 3, I'm going to get a positive 15. It is 15 less than 20. Yes, it is. So this negative, okay, is going to cause the inequality to flip as we are solving these problems. So if these numbers here are negatives, this inequality will flip. Let's try one more of those. Here we have c divided by negative 3 is less than or equal to 6. Well, to get rid of the divide by negative 3, we're going to do a multiply by negative 3. So we'll multiply the other side by negative 3. Again, the number with our coefficient, our letter, is negative. That's going to cause this inequality to flip. So we end up with c not being less than or equal to, but greater than or equal to negative 18. So if we do a graph, at negative 18 right here, this is going to be a closed circle. And I need values greater than negative 18, or to the right of. And the best value to use, if you can use it, is 0 to check this with. It is 0 greater than negative 18? Yes, it is part of our solution set. So 0 divided by negative 3 is less than or equal to 6. Is that a true statement? Let's see, 0 less than or equal to 6? Yes, 0 is less than or equal to 6. So let's finish this up with just 4 problems here just to make sure we understand what to do. So we look at this first one. I've got just a plain old 6x. It does not have a hook, so it does not flip on the inequality. This one we divide by 6, x is less than or equal to negative 3. Okay. One down below it, this one, it has a hook. So this hook causes the inequality to flip. Divide by negative 9, divide by negative 9. N is not less than, but greater than 9, because the negative and the negative make a positive. t divided by 5 is greater than negative 7. This 5 does not have a hook, doesn't have a negative. So I multiply by 5, multiply by 5, t is greater than negative 35. This one, we have a hook. Now this negative is out here in front. Just kind of imagine it being on that 3. So whenever I multiply this negative 3, I'm going to have to multiply it by a negative 3, and that will make that positive. So I multiply this by a negative 3 as well. So these 3's divide out along with the negative. We end up with w not being greater than or equal to, but less than or equal to negative 15. Just always remember that when you multiply or divide through by a negative, if this number here, this coefficient is negative, and I divide through by a negative, you must flip the inequality and solve. You must. So that's a lesson on multiplying and dividing, solving one-step equations of inequalities.